Hi, and welcome back to Module 7, Organic Chemistry. And again today we're going back to inquiry question 1, looking at the nomenclature of the variety of different groups. And today we're meeting the amides, which is another ammonia-derived compound. Now this one, unlike our amino acids, here we have a carbon. The carbon that is bonded to the nitrogen is also bonded to an oxygen group. So it's like a carboxylic acid, which is a COOH, and instead of the OH there, it is replaced with the NH2. So you can see over here we have the carbon bond, the double bond to the O, like we do have in a carboxylic acid, and where here we might have the OH group, we have got an NH2 group there. So for this to happen, like with carboxylic acids, these must occur at the end carbon. So similar to the carboxylic acid where it can only occur on the terminal ends, the NH2 can also only occur on that terminal carbon. So to name them, we're going to name the carboxylic acid there, and instead of having the oic acid, we change that to amide. Similar rules apply like with the amines. If we have some alkyl groups branching off our carbons or branching off where that N is, we are going to use that same rule that we use with our amines. So let's have a look. Similar to the amines, we have our primary, secondary and tertiary amides. So again, the primary amides have one carbon directly bonded to the N atom. The secondary have two, and the tertiary have three carbon atoms directly bonded to that N atom there. So let's have a look at an example. Here we are looking again for our longest carbon chain like we do when we're naming our carboxylic acids. So we have 1, 2 here. So we are going to be looking at an ethanoic acid, 1, 2, double bond, and instead of the OH here, we have got the amide. So it's going to be ethanamide, however you want to call it, instead of our ethanoic acid. So let's have a look at another one here. So let's count our carbon chains, our longest carbon chain, 1, 2, 3, 4, and here now our carboxylic acid group here, and you can see here now we have a methyl group coming off the side. So it's a 4 carbon chain. So we're looking at butanamide, and then we have got a methyl group branching off the N. So it's an N-methyl butanamide. Let's have a go at another one. So again, this one's looking a little bit more complex. So again, we're looking for our longest chain, 1, 2, 3, 4, 5, 6. So we're looking there at hexanamide or hexanamide, however you want to say it, tomatoes. And then we're looking at what's coming off the N here, and we've got one ethyl group here, and we have another ethyl group there. So similar to our naming of the amines, we have got an NN because there are 2 ethyl groups, so diethyl, both attached to that one group. So it's an NN diethyl hexanamide. So have a go at this one. So let's have a look. We've only got one carbon there. So we're looking at a methanoic acid, and then we have our amine group off the side. Sorry, our amide group off the side. So methanamide. Have a go at this one. Where's the longest chain? Then convert it from an ethanoic acid, or an anoic acid rather, to an amide. And then we have an ethyl group off the side. So what did you get there? We'll practice some more of these in class tomorrow.